Today we have to start with a new chapter, call it as Boolean Algebra. The total weightage of this chapter is totally 9 marks. 9 marks on your annual exam. Out of 9 marks, 2 marks 2 questions they will ask, as well as 1 marks 1 question they will ask. 2 marks 2 questions, that is on part B. 2 questions they will ask, each question carries 2 marks, and on part D, 1 question they will ask, that is only 1 marks. That is only for 5 marks they will ask. Only 1 question, 5 marks. Before starting this chapter, you have to know what exactly the content of this chapter. On this chapter, you will study all the logical operators, truth tables, symbols, mean term, max term, as well as all the postulates, how to prove the postulates. Regarding that, you come to know on this chapter. Whereas this chapter, already you come to know the total weightage of this chapter is 9 marks. Is it no? 9 marks, 2 marks 2 question, as well as 5 marks 1 question. But on this chapter, it is mainly designed to circuit the logics. It is mainly used to design logic circuits. We are using this Boolean algebra. And it is developed by George Boole. It is developed by George Boole in the year 1854. In the year 1854, they developed this Boolean concept. And this Boolean algebra is also called it as switching technique. This can also be called as switching technique. And in this, we are using mainly binary numbers. But when they come on number system, there are several types of number system like binary number, octal number, hexadecimal number, like that we have several types. But this Boolean algebra mainly deals with binary numbers only, that is zeros and ones. And here we are able to perform min term, max term, K map, especially kernel map, then truth table, symbols, all these things you will study. And on this chapter, they will going to ask 2 questions, 2 marks. Is it no? One time they ask, what do you mean by tautology as well as fallacy? Then what do you mean by tautology? The result of an expression, if it is always true, then it can be called as tautology. For example, consider a truth table. On this truth table, we have variable A and B. For example, the output become A plus B. 2 0 2 1 0 1 0 1. 0 plus 0 output becomes 0. 0 plus 1 output become 1. 1 plus 0 1. 1 plus 1 1. The result of an expression, if it is always true, then it can be called as tautology. Tautology means the result of an expression if it is always true. True you can say, otherwise 1, then also it is called as tautology. When the result of an expression, if it is always false or 0, then it can be called as fallacy. Whereas one year they ask this question, what do you mean by tautology as well as fallacy? Tautology is nothing but the result of an expression, if it is always true, then it can be called as tautology. The result of an expression, if it is always false, then it can be called as fallacy. Then on this chapter you have to remember who developed this, on which year, what do you mean by tautology, fallacy, mainly deals with binary numbers. But when they come on number system, binary number, octal number, hexadecimal number, as well as decimal number. But here Boolean algebra mainly deals with only binary numbers. Binary numbers means 0 and 1. Now I am going to explain which are the logical operators we have and how to write the Venn diagram as well as truth table. Regarding that, I am going to explain you. When you come on logical operators, there are 3 types. The first one is and the second one is or, and the third one is not. There are 3 logical operators, and or not. For and, in the previous class itself, that is on logic gates chapter, I told you what is the symbol. Symbol we are using to represent dot operator. For or, we are representing plus operator. For not, we are using negation or inverter operator. This NOT gate is also called as inverter gate also. Now, for AND, how to write the symbol, truth table, what are the possible output we will get, then we are going to explain the Venn diagram. Now, to represent AND, we are using maximum. More than 2 inputs we can use. Minimum also 2 inputs we required. For example, A and B is the input variable. Here to represent that we are using D shape. And the output is A dot B we used to write. This is the symbol. Now, which are the possible values we will get? See, for example, here 0 dot 1. Then what is the output in between your dot operator? Then the output become 0 here. Whereas in AND operation, if all the inputs are 1, then only the output become 1. Otherwise, it is 0. Now, for example, 0 dot 0. Then also the output becomes 0. Possible alternatives values we will get. Then 1 dot 1. 1 dot 1. And one more is 1 dot 0. 1 dot 1. Here all the inputs are 1. Then only the output become 1. Here all the inputs are not 1. Or if you want, if you have any confusion, then you can write 2 zeros, 2 1. 0 1 0 1. Like that also you can write 0 1 0 1. Now here 1 into 0, the output become 0 here. 1 into 1, the output become 1. When all the inputs are 1, then only the output become 1 in AND operation. These are the possible alternative values we will get. And how to write the truth table for this one? In the same pattern. Minimum 2 inputs A and B. Here output represents A dot B. This is the truth table and this is the all possible result, alternatives values we will get. Here 2 zeros and 2 1. 0 1 0 1. Now 0 into 0, the output become 0 here. 0 into 1, output become 0 because in AND operation, if all the inputs are true, then only the output become true. Otherwise it is false. 1 into 0, the output become 0 here. 1 into 1, all the inputs are true, then only the output become true. This is the truth table, this is the symbol, this is the alternative values here we will get. This is regarding AND operation. Now, how to write the Venn diagram? That is, consider minimum 2 inputs we required. Consider this is A and this represents B. A and this second circle represents B. And means this and this we used to say. Part A as well as part B both has to be satisfied. Only the place where both part is combined, only that part you have to shade. That is the Venn diagram. Venn diagram for AND operation. In Venn diagram, to minimum 2 inputs. If you want more than 2 also you can consider. But where the place both are connected, that place you have to shade in AND. But when they come on OR, here minimum 2 inputs we required. For example, A and B. And here to represent the symbol reverse C shape. Then connect this, then the output become A plus B. Whereas here D shape we is right, but the output is A dot B. Whereas here A plus B. Then what are the alternatives values we will get? For example, 0 plus 0. What is the output? Here the output becomes 0 because here the output in especially in OR operator, if any one of the input is true, the output becomes true. Whereas see, both the inputs are false, that's why the output becomes false here. For example, 0 plus 1. Here one input is true, that's why the output becomes true here. Then 1 plus 0. This part 1 is 1 and the second one is 0, that's why the output becomes 1 because if any one of the input is true, then the output becomes true. Then 1 plus 1. Here the output becomes 1. This is the alternative values we will get here. Then, how to write the truth table for this one? Consider 2 variables A and B. The output become A plus B. 2 zeros, 2 1. 0 1 0 1. See, First part is also 0, second part is also 0, then the output become 0 here. Because if any one of the input is true, then only the output become true, otherwise it is false. 0 plus 1, here we have 1 true value, then output is 1. Here also 1 plus 0, then output become 1. Here 1 plus 1, the output become 1 here. If any one of the input is true, then the output become true. This is the truth table. This is the alternative possible values in our operation we'll get. Then how to write the Venn diagram for this one? Already I told you, whereas in this case we are talking 2 inputs. That's why I'm going to take 2 parts. One is part A and one more is part B. This is A and this is B. Then here or we are used. Or andre kannadalli ಏನು ಹೇಳ್ತೀವಿ, ಇದು ಅಥವಾ ಅಂತ ಹೇಳ್ತೀವಿ. And ಅಂತ ಹೇಳುವಾಗ ಇದು ಮತ್ತು ಅಂತ ಹೇಳ್ತೀವಿ. Whereas or ಅನ್ನುವಾಗ A ಅಥವಾ B ಅಂತ ಹೇಳ್ಬೋದು. That's why we have to shade A part as well as B part also. Both the part we have to shade here. This is a Venn diagram. Venn diagram for the given and operation. See? Symbol, alternative possible values, truth table, and this is a Venn diagram. In 2 years back there was a question, write the Venn diagram for AND operation as well as for OR operation. Then if you write the symbol, then you will get full marks. See, compulsory you have to shade both the part A as well as part B to represent or especially Venn diagram. Next one, how to represent NOT gate or inverter gate. Already I told you, for inverter gate, maximum itself only one input it will take. For example, A. Then to represent the symbol, first you have to write one triangle, at the end one circle and then one line. This is a representation of NOT gate. And the output represents A bar. Output represents A bar. Now, how to write the truth table as well as alternative values? For example, 1 is the input, then what is the output? Negation of that. Negation of that is equals to 0. If 0 is the input, negation of that it becomes 1. These are the possible alternative values. Then how to write the truth table for this one? For example, already I told you, maximum itself only one input it will take. Then if A is the input, A bar become the output. Then 0, 1. If input is false, output become true. If input is true, output become false. Alternative of input operation. Now here if it is 0, the output become 1. If the input is 1, then output become 0 here. Reverse of input value will get in the output. That is the truth table. This is the alternative value and this is the truth table. Then how to write the Venn diagram? See here I told you maximum will be only one input. That's why I am to take only one circle. This represents, for example, A. Then A bar. See, only the inner part here to shade. There is a Venn diagram. If you want, you can write in another way also. One circle. If this represents A and this represents A bar. Now we have to shade only the outer part. If you want, you can write like this way also. This represents the Venn diagram. Venn diagram for NOT operation. Now once again I am to recall, whereas this Boolean Algebra chapter weightage is 9 marks. In part B, 2 questions. Each question carries 2 marks. And in part D, 1 question, 5 marks. It is also called as switching technique, and it mainly deals with binary number, and it is developed by George Boole in the year 1854. In this, we have truth tables, circuits, min term, max term, as well as we have symbols, kernel map. All these things you will study when you come on operators, 3 types of operators, and or not. In AND, we have the symbol, D-shaped symbol, minimum 2 inputs it will take, and these are alternative values, and this is a truth table, and this represents the Venn diagram. Symbol for 2 variables, alternative values, truth table and Venn diagram. But here, compulsory in OR, you have to shade both the circles. Whereas in AND operation, only the place where both A and B are combined, only that part you have to shade. But when you come on NOT operator, the another name for NOT operator is inverter gate, or we can use negation gate also we can say. Here, if whatever may be the input, the reverse of that will be the output. One negation is nothing but 0, 0 negation is nothing but 1. This is a truth table. This is the alternative value truth table. When you are writing the Venn diagram, compulsory you have to represent only one input, that is for example A, or if you want you can take X also. If you want you can shade inner part or only the outer part you can shade. This is a Venn diagram. In the next session we are going to continue the remaining concept. Thank you for all of you.